So this talk's called It's Complicated. So I'll start off by trying to explain the job I have right now, which is actually fairly complicated. Give you a bit of background. So I was sort of looking after Netflix from a sort of overall technology point of view for a while, last time I was here, and trying to explain to everybody how to use the Netflix open source projects. Soon after, actually, while I was hanging around in Australia, as most of the discussions were going on, I ended up at the beginning of 2014, I left Netflix, joined a venture capital firm. And a slightly different role from normal. Most VC firms, they're partners that figure out, which firm they want to give money to and sort of support them from a more financial point of view, business management point of view. But what I do is add a lot more technology to that. So what I'm doing is still doing lots of conferences, possibly even more conferences. I do a lot of CIO summits and things like that. And what I'm trying to do, sort of to some extent, is this kind of pincer movement for change. You have to get to the management and explain why they need to change to speed up everything they're doing. And you need to do the bottom up with the developers so that they can figure it out. And then there's this middle management layer that doesn't want the change. And so you have to kind of get this pincher movement and get them to move along. So that quite a lot of what I do ends up looking something like that. And what I'm also doing there is trying to find interesting people. You are now all interesting people. Thanks for coming to see me talk. That's part of the definition. And because there's lots of people that want to do a startup and they kind of got an idea and they maybe haven't left their main company yet. And you can't just look them up in a phone book or Google them because they're still in stealth, right? So how do you find the next generation of seed startups? And how does that whole process work? Well, the first thing you want to do if you think you might want to do a startup at some point is get to know some VC firm people way, way early, like years before is best, right? So I'm here. You can contact me if you're thinking about doing something. Always happy to help. We do actually only invest in a tiny, tiny fraction of the people that ever come and see us, but there are lots of VC firms out there, so over all of the VC firms, you've got a reasonable chance of finding somebody. But the first thing to do is to get that discussion going and get some input and some commentary on your ideas. So one part of what I do is try and find these people, and by talking at conferences, there's a few hundred people here, that's a good way for me. The next thing I do is when we're obviously due diligence, and I look at people and I ask the hard questions when we're having the meetings with companies like, what language did you write this in, and what's the technology stack look like, and is it going to scale, and things like that. Sometimes it's an open source project, and I rummage around on GitHub looking at their code to see if it actually makes sense, or see what's there. That's kind of not that normal for VC firm people. And then once we've got companies on board, I spend time trying to make them have a good outcome, right? So I've worked with companies to help them scale their products, to speed up their pace of development, and do sort of cloud migrations and things like that. So that's my sort of the keeping my hands on technology architecture type stuff. And then in my spare time, I write code, and I'll talk a bit more about that later. So this talk is because I have people saying, oh, that's too complicated. And you hear this sort of thing, let's simplify it. And quite often, if you hear someone saying that, by the end of this talk, I want you to question that. Like, is it really too complicated, or is it just a bit unfamiliar, right? There's a difference between being overly complex or overly complicated and just being something you haven't seen before. And I'm going to talk about this in 3 areas. I'll start by talking about in our lives, in our daily lives, what are the things we do that are really complicated? And then I'll talk a bit about our work situations and how we organize work, and then I'll talk a bit about the technology and the things that we build. So our lives are complicated, and there's a great quote from Douglas Adams. He's trying to figure out, what's the meaning of life, the universe, and everything? It's all too much, it's all too complicated. But it turns out we actually deal with life, right? There's lots of complicated things going on, but we figure out how to deal with it. So what does it mean when somebody says something's too complicated? And I think it really comes down to this. What they're really saying is that there's too many moving parts, and I can't figure out what it's going to do next, right? So that's my kind of working definition. There's all kinds of things around complexity and chaos theory and whatever, but fundamentally it says I can't figure out what it's going to do next. Means it's not intuitive. So how do we build things that are intuitive? In fact, what do you already do? So here's an interesting question. What's the most complicated thing that you can deal with intuitively without thinking about it. Think about that. Right. Got anyone here use Emacs? Right. I was using Emacs like 30, 40 years ago. It's pretty complicated, isn't it? But you're typing, and you're not really thinking about it, and your hands are doing something to the keyboard, and code is appearing. Maybe use Vi, or maybe you just know how to get back out of VI if you accidentally get into it. Colon Q, colon, whatever. Colon Q, exclamation mark, right? So there's a bunch of things where it is, if you just sit somebody down at Emacs and say go, they're going to go, I have no idea what's going on here, right? So that's the problem. So we're capable of understanding and modeling incredibly complicated things inside ourselves. What's another really complicated thing we do every day? Yeah, driving. Just think, just drop an alien or somebody from a country that has no cars and stick them in a car and say, okay, just drive across Brisbane now. And you can't work out how to operate this thing. The cars themselves are very complicated. The behavior of other road drivers is really complicated, the road rules. And yet, this is something we expect everybody in society should be able to do. I mean, there are a few people who are sufficiently disabled one way or another that they can't actually drive, right? But it's a tiny, tiny proportion. So that's one of the most complicated, dangerous things that we ever ask people to do. And every time we do screw up occasionally. But it's a thing that, because everyone expects you to be able to do it, and the tools and the way cars are designed and the way roads are designed, they follow patterns. They've actually decided that maybe, the accelerator should be on the right, pretty much all the time, and the brake should be, so the brake should be in the middle, and maybe there's a clutch or whatever. So they've got patterns that make it easier to deal with. So some of the intuition, you can go to another country and they'll drop you in a car, maybe the steering wheel is on the other side, and it's a brand of car you've never driven before, and you don't get a driving lesson from the car rental person. They just figure out you should be able to do it. So there's quite a lot of intuition there. Interesting to think about. I actually, I have a fun little car that I take to car shows, and I won this prize last summer, the Needlessly Complicated Italian category at the Concours de Lemons, which is a car show for strange, weird, and busted cars. It's held in Monterey. If you're into cars and you can be in the Bay Area in August, just go there, go to Monterey for a week, and there is an immense number of car shows. This is the weird one where people bring randomly strange things. This is a Citroen SM. In 1973, it's one of the most complicated cars ever made. It's got a hydraulic circuit, more complicated than most cars' electrical circuit. That's also my wife, which is another complicated thing in my life. Relationships are complicated, but we deal with it. There's lots of good value in relationships. And the funny thing is, this is actually a French car. And I won the Italian category. I actually entered the French category in this thing, which was the unmitigated Gaul category. I think there was a soulless Japanese rust box or something. There were a bunch of categories for different naked cars. But none of the Italian cars actually worked that day and made it to the show. So all the other Italian cars were no shows. So I won it because I have an Italian engine. It's got a Maserati engine. So it's so anyway, so that's kind of a fun thing. I have a needlessly complicated car, and it was a needlessly complicated situation. We have fun times. So what's another thing that you do? What's one of the most complicated things we've ever built in our lives? And you probably have one in your pocket, right? Think about the smartphone. Like we all have them now. You go back 5 or 10 years, you'll talk to our kids about the times when you didn't have a smartphone. How did you even exist, right? Because you live on this thing now. Interesting story. I was, soon after the iPhone came out, I think in 2007 was when it came out. So sometime in 2007, 2008, I was just standing around at a party, one of those sort of barbecue things, a lot of friends standing around, and somebody was carrying a small girl. She was not even 2 years old, and she started mumbling to him. We couldn't even understand. He got out his iPhone, gave it to her, and she starts viewing SpongeBob videos on YouTube. And the rest of us are sort of jaw-dropped looking at her, because she's just, she's operating this thing. And that was when we realized that they built a user interface so intuitive that pre-verbal kids could use these devices. And I've never seen anyone up to that point, at that young, figure that out. I actually went back to the next time Netflix had a hack day. I went to build a Netflix for Kids app, which which is really easy because it was designed for preschool kids, so I had no words. It made the UI really easy. But it was around the time Netflix was starting to think about its whole Netflix for Kids program, and I just did a hack day project of sort of one idea for that. So that's an interesting thought. But then you take your nice, simple phone, and you customize the hell out of it, right? How many apps do you have on your phone? Well, I've had an iPhone since they first came out, and there's a screenshot. That's what my phone looks like. I only have all of my apps. Actually, I guess some of them are hiding, but I just have one front page, and everything's hierarchical. And I give this phone to my wife. She can't figure out anything on it, right? I pick up her phone. I can't find any of the standard things. They're all scattered around. So we've taken our phones, we've personalized them to the point where we can't even figure out. So that's complicated, right? Anyway, another interesting thing, there's this book that just came out, Thing Explainer, complicated stuff in simple words. So Randall Munroe, you probably know from XKCD cartoon. And he figured out the 1,000 most common words in the language, because 1,000 is not one of them. And he has an entire book that explains really, really complicated things, like this is what's going on inside a phone. Just one of the 60 or 70 things in this book, and the book just came out a few weeks ago. And he explains it in simple words. I've been reading through it. It's a brilliant book. Christmas present for any kids in your life, anyone wants to know how anything works. It's an excellent book. But you can see there's all of these complicated things. There's a direction feeler, there's a big sound maker, there's a listening box, there's a radio feeler, a tiny power gate, and extra memory holders and things. A pocket mover, this little vibraty thing. Anyway, so what's going on inside these things? Inside these little pieces of glass and aluminum is an incredibly complicated device with incredibly complicated apps talking to back-end systems that in a typical modern mobile app has 10 to 20 APIs to different vendors for all of the logging and authentication and all the different backends it talks to. They're extremely complex things, but they are something you can give to a 2-year-old that will use it. So that's, how do we build systems that have that kind of intuition is one of the interesting things that we should sort of work on. So that's our own lives. So just having something be complicated isn't necessarily an issue if you spend enough time making it intuitive. So that's good. But then we go to work, and we have all of these the way our work's set up, the way that our organizations are put together is pretty complicated. We're trying to build things. We're trying to organize large groups of people towards a common outcome. And there's a quote. This is actually from the Netflix culture guide. If you want to build a ship, don't drum up the people to gather wood, divide the work, and give orders. Instead, teach them to yearn for the vast and endless sea. And they will build some better ship thing better than you thought of, right? That's the idea. So this is a systems thinking approach, and it's something that Netflix has got very good at. It's like we've got a very singular purpose. We've got everything figured out about where we want to be. We can articulate the purpose of the company and the direction. Everyone just go figure it out amongst yourselves and go and yearn for this vast and endless sea. One of the neat tricks that Netflix does is at the staff meetings, we always used to go around the table and talk about, so what have you seen on TV recently? We've been to the movies? So the first 10 minutes of an hour-long meeting is spent discussing content, and that's in the brand, right? It sort of gets you into the mode of thinking about this is what this company is about, right? It's a neat little trick to do that. So spend some proportion of whatever your technical meeting is at a staff meeting level, talking about the business itself and the value you're delivering to customers and your experiences in that place. And it's a nice trick for doing that. Okay. So this came from the culture deck. The Freedom Responsibility Culture came out in 2009. And it actually, Sheryl Sandberg thought this was so good that she actually persuaded Reed Hastings to join the board of Facebook. So he got a board seat out of publishing a PowerPoint. That's not too bad. And there's a lot in here, but think of this as freedom and responsibility means you're free to figure out how to locally optimize what you need to get done, and you're responsible for the outcome. Now, if you look at what actually is going on in Netflix, and if you look at it from the point of view of a normal company organization that's much more hierarchical, it looks totally chaotic. You know, what's the plan? I don't know. There's just lots of people rushing around. It's more like an ant's nest swarming on a piece of food and dragging it back into the nest. It's like, we have to launch in Canada, and we have to figure out how to do French-Canadian, and okay, so we have to internationalize everything. Well, that means we have to get into the cloud because the current code base in the data center is not internationalized, and we had a whole year of just scrambling every piece of that, and that got us the first international site and the move to the cloud. And we had to also get off of Oracle and move to, you know, Cassandra and all of those kinds of things. There was all these sort of things that got rolled into, well, with one goal: we need to launch in Canada, and we need to get the French-Canadian support up so we can do all the other languages and countries in the world. And that drove, back from that, all of the technology drivers. But I do lots of talks on this, and a few years ago, I was doing a talk about the Netflix open source program and all the things we did, and one of the audience said, well, this is great, but I don't have those kinds of engineers. I can't do what Netflix does. I don't have these people. And I looked at the nameplates around the room and said, but we hired them from you. All the people we have were somewhere else. They're mostly senior people. They were working at, you know, all these big companies. So you were, you know, if they're the same person, they didn't suddenly, we don't have like a cloning machine that generates Netflix employees and sort of chunks them out, and they come out here and invent, you know, reactive hystrixes and things like that. We got Ben Christensen from Apple, where he was stuck in a cube, told not to talk to people, and we got him at Netflix. Noticed that he was good at speaking, started sending him to sort of QCon and GOTO conferences. And 2 years ago, I was teaching a tutorial with him on YOW. And now he's working with Eric Meyer, who's at Facebook. So, you know, that was you know, a really good example of somebody who was his talent was being minimized in one job, and then we just maximized it and pushed him. And he actually commented to one day, it's like he felt he grew wings, and we kept saying, fly higher, fly harder, right? That was a great piece of feedback. So think about, how can you do that with people in your organization, right? And what is really happening normally is HR makes you say, treat everyone the same, and you can't be special because it's not fair and whatever. So you have to figure out a way to take the really talented people and create something like a distinguished engineer program or a best of the best or something like that. Because those are the people that will leave and join your local Netflix, and then you'll wonder why they can do stuff you can't do. So that's very important. The other thing is this idea of sort of trust but verify. So there's high trust organization. You don't just, I trust you're going to do that and then not look at what they're doing. There's a lot of verification in there as well. And one of the examples, and I've told this to a lot of people, I've still not really heard of anyone else that does this. So Reed Hastings, the CEO of Netflix, has a quarterly one-on-one with everyone in the company down to director level. So he has about 200 one-on-ones a quarter. And during the time, I was at Netflix almost 7 years. Every quarter I had a one-on-one with him. He'd ask, how's the Amazon thing going? I'd ask, who's, you know, I'm worried that someone might buy us. No, it's not happening because of this or whatever. We talked through anything that was going on in the company, what's going on with the new marketing department, or anything in technology, anything that was worrying me, anything that he was thinking about. And what he's doing there, he actually doesn't make a huge number of decisions. He's devolved the decisions. He's trusting that if he hires the right people, they will figure out how to do everything. And this set of meetings he has is the verification, right? He's talking to everyone. So his VPs have directors and whatever reporting to them. And he's actually getting the director, he's talking to the director, the people that report to his management chain, as well as figuring out what's going on. So when anything happens in the company, he knows the people, he knows the context, and he can kind of concentrate his time and attention span on the most broken thing that needs to be fixed, rather than trying to hand manage and guide everything. So this is that trust but verify, freedom and responsibility culture. Now, Netflix regards this as a very hard to copy competitive advantage, and it is very hard to change company cultures to that. But if you're starting a new company or you're small enough that you can change culture, then think very deeply about the culture you set up. And what's really happened over the last few years is this change. Nordstrom, 150-year-old retail company. They said they finally figured it out. They were optimizing for efficiency, when they should have been optimizing for speed. That was the operations VP talking about it. Once they figured that out, they started going, their pace of development went from quarterly releases to more than one release a day, right, for the teams. The standard release cycle was quarterly before. And the number of problems they had over that quarter went down by a large proportion. It was like a third or a quarter. And then it turns out that they actually did it with a smaller team and because there were so many fewer meetings and everything was happening more efficiently, it was a leaner process, they actually spent less money at the end of the day to get stuff done. So they went back to their the team that figured this out went back to them and said, okay, well, we're about 10 times faster at this, and it's safer, and it's cheaper. And so, hang on a minute, but we were telling you to optimize to make it cheaper. But you don't, if you do that, you end up causing these externalities that make it slower, and because it's slower, it ends up more expensive. So there's this problem that you don't get what you optimize for if you just go on a cost-cutting exercise. You end up overrunning your costs. If you run fast enough and you do it intelligently, that because you're running so fast, you don't actually have time to spend money, and you're much more efficient, and you end up underspending. So you get this just as an outcome of the fact that you're running really quickly. The other thing is that there's premature optimization. Everyone knows about, don't optimize until you're sure which things need to be optimized. When you're looking at this, when you've got an unknown new thing you're building, so your brand new features, those things should be fully agile, you should be iterating, you should be trying things out. When they sort of mature a little bit more and then they become boring and they stop changing, that's when you optimize them. You look at, okay, where is most of our dollar spent going into things which have stopped changing? Do a few more changes to optimize them. So that's kind of the right point to do it. One of the problems we get here is that a lot of big companies have processes. And they have the processes because something bad happened. So say, we should have a law against that. We should have a rule against that. Countries have laws to prevent bad things happen because a politician has to be seen to be doing something, so they propose a law against the thing, right? If you took all the countries in the world, you took all of their laws, and you subtracted out all the laws that are the same everywhere, and look at what's left, you'd be able to see all the bad things that happened in the world, right? Because the differences are the bad things, right? And you see that across companies. You see HR manuals that list strange things that you shouldn't do because somebody once did that 5 years ago. And what you're doing is you're building up scar tissue. You're building up a complex process. Like your release process probably has all these checks in it because somebody once did a bad thing and something broke when you released it. So how do you tear all those out and build something which is much more agile and lightweight and doesn't have all those things? And what you're really doing when you create a process with checks in it is to say, we don't trust people to know what to do at this point, so we're going to force them, we're going to verify, we're going to tick box, have a sign-off that makes sure you did this the right thing. And what you're really sending is a message that says, we don't trust you. We don't trust the people that are operating this process. And this is a sort of manufacturing model of thinking, like a car plant, right? You've got the management layer that design the cars and manage everything. Then you've got workers that are hourly paid and they turn up and they just work the production line. And this is management methodology called Taylorism. It's very efficient if what you're trying to do is build cars. But the people working on the production line in a development organization aren't, you're not just cranking out widgets, right? You're building, you're solving complex problems, you're designing things that have never existed before. So it's a different problem. And what happens when you impose this process is that people get frustrated and they leave, and that drives out the talent. So it's important to keep lightweight processes with these systemic goals. This idea, like, remember that quote about building a ship? That's a system thinking goal. Like, okay, let's teach you to yearn for a better whatever it is you're trying to build, and let everyone figure out what they need to do to get there and trust that they will do that. If you find somebody that you can't trust in that situation, get rid of them. Like, move them somewhere else where they can't harm the process, right? That's the trick. And this comes out, I've been talking about systems thinking a bit. This is a really deep book. It's one of those things where I spend years thinking about stuff and I've got these half-formed ideas and things I've seen. And then every now and again you read a book that sort of says, oh, here's the history of the last 40 years of this subject, and here's how all the bits fit together. And suddenly all these random pieces that sort of fit together click together in your mind into sort of a proper, the jigsaw puzzle pieces fit. This is one of those books. If you get into this book, it's mind-blowing what is in there. This is, see if I can explain this point. So purposeful system, right? That's a company, have a purpose. Right? Netflix's purpose is better entertainment, and capturing the moments of truth, meaning when you sit and decide, I've got 5 minutes or 10 minutes or an hour, I'm going to watch something on Netflix, right? What are you going to do? Systems view of development. So this is development. This is a developer conference. We care about development, right? And plurality, meaning don't do fixed processes. Don't do things one way, right? How do we end up with something that's flexible? And what this book is trying to teach people is how to build organizations that evolve. And you're optimizing for the ability to evolve, which is part of that whole agility thing. And the dimensions, function means that any one thing. So if you have some functional thing, it doesn't just have one function. It can have lots of functions. It can have different functions for different people. The example he uses in the book is a car. A car is a function for getting from A to B, right? But it's also a status symbol, right? So and it's also, if you're a car company, it's a thing you're selling, right? So it has different functions for different people. And I'm not saying that what you tend to do when you simplify is you say, I have these things and it's confusing, I'm not sure what this is for, so I'm going to say it's for this one thing. And you focus, right, on a single function and it makes it simpler and clearer and easier to understand, and you just froze everything and you just drove out a lot of innovation and ability to evolve. So keep that plurality of function. Understand that things the reason to have something is not fixed and it's not singular, right? Structure, like corporate structure, you've got the hierarchy, but you've also got the end-to-end flow across an organization. The way Netflix is organized is a consumer to producer flow, even across the buildings. With the teams are sort of arranged end-to-end, or they used to be, they just moved buildings, not quite sure what the new layout is. But the idea was that I build something and I know who my upstream consumers of that thing are. And yes, there's a company hierarchy somewhere in there, but that's not the primary structure that matters. And there's plurality of process. Rather than having a fixed SDLC lifecycle that forces you into a waterfall model with phase gates and things like that, we'll have what looks like a process is actually an artifact of the system. You could say at any point in time there appears to be a process for getting something done, but every team's doing it slightly differently and it's evolving and they're constantly trying better ways of getting stuff done. There may be some common tooling that makes it easier to do things that have been figured out, but anything that's new and novel and around the edge is going to be rapidly iterating. Right? So that's, don't simplify down to one pipeline and one language and one way of doing everything, because you're driving out the ability to evolve. All right, so we're talking about building things. So inside the things we build, it's a little bit complicated. You'll be the first person to put Conway's law up. You'll probably see this a few times in the next couple of days. Basic thesis of this article is that organizations that design systems are constrained to produce designs that are copies of the communication structures of these organizations. Right? So what that means is that if your company is organized as a bunch of cells that own a feature and they know who their consumers are and they know who their dependencies are, you'll naturally build a microservices architecture without even knowing that it's supposed to be called microservices, because that's the way it works. Right? That's the model that we're doing, and that's why Netflix is held up as an example of a microservices architecture. It's actually, that's really backwards. It's a microservices organization. The architecture came out of the fact that we were set up that way. Now, if you've got a stovepipe-like architecture in your company or your organization where you have handoffs between teams and you're trying to design and build a service, and that service, part of the service is being built here in Brisbane, part of it's being built in India, part of it's being built somewhere in Europe, you're going to have real problems because those different pieces, they've got to coordinate over a wide area to get everything sorted. So what you want to do is give each location in your organization full ownership over its service and have a stable API to them, and they can iterate behind that API. You don't need to know how many times they pushed code behind that API. in the last week. You just call the API, and then you have a negotiation when the API changes. So we're talking about building stable APIs between systems, or evolvable APIs. Typically backwards compatible is the best way of thinking about it. You can add stuff to an API as long as you don't break what was there already. And then when you get this level of ownership, we get into this DevOps thing, right? And this is before the word DevOps was invented. This was what Amazon were talking about, and what Netflix was listening to Werner and saying, okay, we're going to have an organization where the developer builds something, then they operate it themselves in production. So you build it, you run it. There's a neat trick here. When you're in Holland, put this up as the first slide because he's Dutch and the locals like that, right? And that French quote I had from the Netflix, but I did that when I was in Paris as well. And I got some nice pictures of the Great Barrier Reef coming a bit later to make you guys think happy, right? Butter up the audience time. So you've got all these systems and you're managing them, and if you've got a monolithic application which 100 people are working on, you have 100 people working as a team producing this big block of code which you're updating, and you're having trouble probably getting it updated, but it's only just one box on your diagram. And the thing is, these monolithic apps only look simple from the outside. When you look inside them, they're a big mess. We have the big ball of mud people in the house somewhere. We have talks later. There he is. So we can talk, there's a big ball of mud, or there's a spaghetti code. And you know this because if you've got a monolith and you say, well, obviously we can easily split it out into microservices because it's all very nicely segregated inside because we wrote the code really well. And it turns out, no, it's never like that. These methods are all tangling in, and they're reaching through getters into far corners of the system. And if you ever try and draw the object hierarchy of your monolith, you better have a big long row of cubes. We did this once at Netflix. There was a row of about 8 cubes in a row, and we had a wall, and we covered it, we papered it, we wallpapered it with our object model hierarchy in tiny print, and it was 50 feet wide. That was one of the reasons we went, yeah, we have to chop this into chunks which are more reasonable. So what happens when you get to this microservice model, and I regard microservices as a tactic. It's an organizational tactic for just going faster. You're breaking things into chunks which you can deal with. And you're enforcing separation. You can see the boundaries, and it's much harder to reach through a stable API to do something bad and sort of grab hold of a getter on an object on the other side of the code base. So the separation makes them actually less complicated overall. And you could argue whether the interactions in a so there's all of let's say you've got 100 features that you're putting into the new release of a service. And then you've got 100 separate microservice releases. The microservice releases have very well controlled interactions, so that there's not so much interaction complexity there. But these 100 features in your new monolith release will interact in ways you don't expect. That's the problem. We're trying to avoid that problem. So this is what I built a simulator for microservices. I told you I was writing some code. I've written sort of an actor-based simulator in Go because I wanted to learn Go. And I'd written something similar in a language called Occam, which some oldsters here might remember as the transputer language from years and years ago. Anyway, so I had this highly parallel sort of protocol simulator, and I figured out that I could use it to simulate microservices. And then code started escaping onto GitHub out of my head, basically. So I sit there and I have an idea, and it turns out Go is a very productive language, and I'm having fun writing it, so I'm just putting stuff out there. So you can go look at the GitHub site. So this is an architecture that I came up with, and I've got some labels to show you what's going on here. This is the sort of connectivity diagram for it. So what we have, this is an IoT example based on, I was at the React conference, and this is a React-based example. They said, we've got this IoT reference architecture for React, and I tried to understand what the architecture was and built this model for it. So somewhere on the left you have, let's say you have a thermostat in your house, and every now and again it calls this endpoint saying, hey, the temperature is whatever it is, 20 C, and the setting is at whatever, 21 C. That goes into the system. Then there's an endpoint that your mobile phone is connected to say, yeah, your house is at 21 C in this, whatever it is. All right? And then there's an analytics endpoint that once a month you get an email that says, your temperature and your energy consumption over the last month was this. And that's kind of generic IoT thing. I have a Nest, one of those Nest thermostats at home, and that's kind of what it does. So that's a fairly generic architecture. You typically have those kind of endpoints. Those hit a load balancer. This is all laid out as if it was on AWS. So that's an ELB. Behind it, you see, if you look at the bottom one, you can see 6 red dots, and the red dots are in pairs. That's because they're in zones. You've got zone A, B, and C. You always want to use AWS across 3 availability zones, and then you can lose a zone and everything still works. Hope if you do it right. Well, in this architecture, it works anyway. So that's a normalization service. There's a stream service, analytics service, so that's what you're accessing behind the load balancer. Then there's a message queue in this case. That was their architecture. And then they've got an enriching service, and then there's a React KV store, which is holding the sort of the most recent data in some normalized form, right, where they've enriched it a bit, I guess. So that data is then sent out into another message queue to this ingestion service, and then the stream service picks off the message queue as well. And then they've got a React time series for doing the analytics, and there's a KV for the general React. React has pluggable backends, and they've just launched this time series. That's why they're trying to highlight this. So that's, I can very simply, by just describing each of these tiers and the dependencies in a little input file, create this model. What I'm actually doing, every one of the dots on here is a Go routine. Right? And every one of the lines on here is a channel. And what I'm doing is I'm simulating TCP with the Go channel, right? And I'm simulating a service with a Go routine, and this is all running in memory on my laptop. So why would I want to do that? Well, I can run 100,000 node microservice architecture on my laptop in a couple of gigabytes of RAM. Right? Now, if you try and do that on AWS, you get a really big bill at the end of the month. Right? So you want to do that. And then, so why is that interesting? Those endpoints actually inject traffic. Once the thing is initialized itself, they just start sending messages in, and the messages are actually being forwarded through this network. So I have real traffic going through. I have gets and puts, and it's mostly fake traffic, but it's basically gets, puts, and random routing through the system. So I'm keeping all this stuff busy. And there's storage at the back end, things like that. And there's replication going on. So when you see those 3 React KV nodes, the data's triple replicated. You write to one, it writes to the others, and the other one. Now, the other neat trick is that I've defined this to be a single region, 3 zones in one region architecture. With the model, with exactly the same model, I can say, well, let's scale this up to be a multi-region architecture. And it looks like this. So I still have the same endpoints, but now the endpoints are DNS splitters, right? So they say, if you're on the east coast of the US, go to Virginia, and if you're on the west coast, go to Oregon or whatever. So we've got the 3 endpoints, and you can see that the ingestion system is local to the region, but the analytics system is global, right? Thermostats don't generally sort of hop between, houses, so we can sort of just say if you're east of the Mississippi. And there's this problem, that the Mississippi riverboatman problem, which is if you keep zigzagging across the Mississippi, you keep hopping between the east and the west, but it's a corner case. We can figure that out. This Netflix always split on the Mississippi, basically, as east and west. So this is a nice architecture, and actually on the model, this is just 2. I can actually go to 6 regions in my, I've got within the simulator, trivially just add more, and this just gets more and more complicated. You end up with a diagram which I've ended up calling the Death Star diagram, and you'll see a few of those over the next few days. So everyone has their own Death Star diagram. It's really complicated looking. So what I'm actually sending traffic here. So the problem now is, okay, instead of having this monolithic app where I'd sort of attach a debugger to it and see the call stack, now I want to see a distributed call stack across all my services. And I'm tracing them across there. So what I'm actually doing is on every request, I'm throwing a context into the request. So it's a little extra piece of information that piggybacks on every request. And you should do this on your own systems, right? And there's a number of different ways of doing this. Google built a paper called Dapper, and wrote a paper called Dapper about their Dapper system in 2010. And Twitter built a thing called Zipkin, which is an open source implementation of Dapper. And I've actually instrumented my simulator with a Zipkin compatible sort of set of APIs, or actually it's not, the APIs aren't compatible. The data it generates is Zipkin compatible data. So I'm actually generating data as if a real machine was there, which I can feed into the monitoring tools, and they can't tell that there isn't, you know, hundreds of machines generating this traffic. They're seeing the same inputs. So what you want is a transaction ID, a parent ID, and a span ID. So every time you hop between two nodes, that's a span. But you need to know the parent span so that you can build the tree, and you want to know which transaction all of these spans are related to. So somewhere up the top here, there was a call that was transaction number 98. And then I got to this stash, which is a data access layer service, which is in zone C, and it decided it wanted to do a put, so it wrote into a React node in zone C, right? Because you tend to stay in zone if you're writing. It's closer. And then that node says, oh, I need to replicate this data to the other region. So that's US East 1. It sends it to US West 2. And I'll pick a node, zone A. And when it gets there, that node will replicate it into zone B and C, and I'll replicate into zone A and B. So at the end of that write, that single put caused data to appear 3 copies in 2 different zones. And this is the way Cassandra and React do writes. You know, all of the writes into them get replicated in this way, multi-region replication. But if you could tag that, what you put in the header is this just, you know, T898, P895, S96. That's effectively what's in the header. That's the triple of numbers. And you can walk through and you just regenerate. Every time you do a new span, you pop your current span into the parent slot, you leave the transaction ID alone, and you work across. So by just passing 3 numbers through your entire system with every request, you can now unstitch your entire system set of requests. And what the simulator I built does is it writes the output in a format which is basically there's a standard JSON representation and there's a standard thrift representation. So I generate a JSON output file which is the thrift log of all the requests flowing through my machine. And the nice thing about that is that Twitter wrote an application called Zipkin, which you can get from the Open Zipkin thing on GitHub, which visualizes that. So this is a diagram based on the messages that it saw flowing through the system. And this is the dependencies thing, so you can read it very well. But there's the ELB, there's the service, the stream service, there's the ingestion message queue, and then it talks into the back end, and then there's all of the replication traffic going side to side. It gets a bit more complicated to see, right? Well, that's nice. I've just regenerated the diagram, but here's the other display that is really useful. So this is like when you pull up your developer mode in Chrome and you want to see what's happening to your web traffic and which call went where. This is the same thing. So here I've got my put, and then I've got replicate at the bottom. So you can actually see the flow of traffic coming down through here. This, I think, was for a single region one where I was looking at it. So yeah, these are all US East 1, right? The other neat thing I did is I looked up the actual IP address ranges of that Amazon has in each region and stuck them in my simulator. So I have actual IP addresses for these simulated nodes which pretend they're real machines in the real world. So this is useful because I'm simulating something, but what I'm now doing is I can now drive the development of this tool and other tools that are used to monitor microservice architectures. There's a few other vendors now either using my simulator or trying to figure out how to use it, where you can create a really nice big complex architecture that would be too expensive to run on AWS, and you can feed it into your monitoring tool and feed live data into it. That's where I'm going with this. I want to build tooling that successfully monitors systems. So there's a few lessons here about the microservices. Notice that everything I did was symmetric in zone. I've got 3 zones. Everything has 3 zones. There's a clear symmetry there. If you enforce that symmetry, then you can kill a zone, and you still have 2 out of 3, and everything still works, right? You'll hear from Dave Hahn that's doing a talk about life in the engineer at Netflix talk later today or tomorrow. He talks about the kind of testing they do. And there's a few talks in the next couple of days you'll see where people are talking about this chaos monkey idea and the ability to shut down chunks of your system and still have it work. The symmetry is really important for that. And what we're really trying to do here is that the thing that makes a complicated thing intuitive are these three things. Like, what are the invariants? Right? You know, throttle pedal always on the right for a car, right? The ability to reach into the user interface on a phone and manipulate things. All of those things are important things that make it simple. You do everything the same way every time, and you learn how to do it once, you can apply it somewhere else. Some of the invariants you get that are very useful in monitoring systems is you look at the amount of traffic coming into a service and the ratio it with the traffic going out. So for every incoming request, you get 3 outgoing requests, let's say. Right? So that ratio, could monitor it, should always be 1:3. Now, if it's 1:2 for a while, one of your outbound things is broken. If it's 1:4, you're retrying your outbound stuff, right? So there's a number of ways where you can very sensitively, it doesn't matter what the actual traffic level is, but you can do these flow balanced invariant things to go find stuff. And this whole idea of using isolation makes it much easier to iterate on things. So here's the kind of another comment from the from Jamshid Gaharajadeh. Now I can pronounce that. Garajadagi. There we go. I actually think I'm probably going to meet him next year because I can ask him how he pronounces his name. So we see the world as increasingly more complex and chaotic because we use inadequate concepts to explain it. Right? That's the key thing I'm trying to make here. And when you understand something, it no longer looks complex. You know, the fact that we have cell phones in our pocket is a natural thing to a 10-year-old, right? You know, you go back to, they can't conceive of a time when everything wasn't online. There's these arguments like, you know, there's TV sets that only show TV shows at certain times of the day. What's this? It's broken, right? And you get kids walking up to TV sets and trying to swipe them because they should behave like an iPad. So, you know, once they've got a concept in their head, you know, everything else is sort of, they've got these models. Anyway, that's the key point I was trying to get across, which is that when you've figured something out, how do you make something intuitive, and how do you learn things, and how do you get through this point? So I think a lot of the comments that I see about, oh, microservices are too complicated, it's just that they're unfamiliar. So try to get over that unfamiliarity and try to understand what are the invariants and symmetries you've got in your architecture that will help you manage it and deal with it in the longer term. So I have a picture of the Great Barrier Reef. This is my wife at moonlight, silhouetted on a beach, very simple, pure moment, you know, on the Heron Island on the Barrier Reef. I think it was 36 hours to get there, 3 aircraft, 2 hours on a boat, a whole lot of planning, whatever. But we got the simple moment at the end of it. We got to see turtles laying eggs and things like that. So had a good time. We went up to Gladstone and off the coast there. So if any of you, I know it's one of these things where you live somewhere, you never do what's right on your doorstep. So if you're local here and you haven't been to Heron Island, just go to Heron Island. It's just up the road, sort of. Anyway, thanks very much. And I think might have a cup done. Okay, thank you very much.